Hello. Today we're going to be talking about we're going to start the unit of linear equations, and today it's kind of a review. You might have done this in 8th grade, 9th grade. I'm doing it again in 10th grade. It's called equations of lines. So in the last class, you spoke up about, so let's see, the name is equations of lines, and specifically, equations of lines. And what we're going to be doing is looking at how we can look at the equation of a line or a linear equation, and we can sketch a graph, and we can pick out some important information about the line. Once again, this might be mostly review from 9th grade or 8th grade. First of all, we said a relation was a set of points. And we got the set of points we saw in the last class that the x and y were connected by a rule. So the rule was, how we create all these x, y's, right? So, for example, the rule was y equals 2x plus 1. And like in 7th grade, 8th grade, your teacher started with a chart. And, you had the x and the y, and the teacher chose the domain for you. If you think about it, the domain always had 0 in the middle, right? So it's always like -2, -1, 0, 1, 2. That's not a coincidence. We know what he or she was trying to do. And so we needed to take -2, substitute it into the rule. So we got 2, -2 plus 1, that was -3, right? And then if we did 2 times -1 plus 1, that gave us -1, and then 1, and then 3, and then 5. Once again, so when we plug 0 into the rule, 2 times 0 plus 1 is 1. For 1, 2 times 1 plus 1 is 3, and for 2, 2 times 2 plus 1 equals 5. So what you did was you created this table, and then from the table you actually created a set of points. -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. And then what you did was you plotted these points. I'm going to make a sketch. It's not going to be the best, but it's okay. So you plotted, let's see, you had your graph. This is your x-axis, this was your y-axis, -2, -3, right? And then it was -1, -1, and then it was 0, 1, and then it was 1, 3, and then it was 2, 5. You plotted all these points, and then you connected it with a line. Right? That was initially, this was like 8th grade, right? 7th grade, 8th grade. But then we're going to hold off on that because, so after you did that, your teacher introduces to the idea of slope. Slope. Remember that n equals slope, and you were introduced to the idea of the y-intercept. And B was the y-intercept. And that would have the coordinate of 0 blank. That was this coordinate, right? So this was your y-intercept. And the slope was rise over run. We know now, we don't want to say rise over run. We want to say change of x. Change of y over change of x. This should be familiar to everyone, and we can see that in the chart. We saw from the chart that, when we go up +1, plus 2. Change in y was +2, change in x was +1. Change in y was +2, change in x was +1. And so on, it was constant. We'll talk about that in a second. Let's get that out now. So let's see. Let's just talk about a couple of just some theorems and axioms, just some statements. I just want to make a statement first, between any two points, there is only one line. That's kind of interesting when you think about it. That's known as an axiom. Once again, if you have 2 points, there's only one line that goes through those 2 points. And then the other one is a theorem. And the theorem is that, right, between, what did I say? On a line, the slope between any 2 points is constant. That's kind of interesting, but we see that here. We know from the rule, we created a set of points, we created a table, a set of points, and we discovered that as y changed, x changed, and it was constant. +2, +1, +2, +1. That's why we study linear equations. That's what's important about it. Okay. And so we saw, right? You were taught how to graph it. Graphing using y-intercept slope. So this was, you moved on. So your teacher showed you this and said, you know what? We can use the equation to graph lines. So you said, you know what? First, write the equation, write the line in the form y equals mx plus b. Right? You needed it to look like that. Right? What was the next thing? Did you recall the next thing you were told? First, what was the next thing? You were told to identify the y-intercepts, which you said, okay, that's 0b. That's 0b, so you identify and plots. Well, yeah. And then the third thing you had to do was write the slope as a fraction. Now that's all that stuff from like 7th to 8th grade about like fractions and decimals, fractions and numbers, because we know from over there it was 2x plus 1, we needed to write 2 as 2 over 1, right? We need to write 2 over 1. I need a new pen, sorry. So when we wrote 2 over 1, then you remember these are the directions. So 2 is out of the rise. In this case, because it's positive, you knew it was up 2. And because 1 is the run, it's 1 to, and it's positive, it's 1 to the right. And then you were taught, okay, now we can start graphing. And you were taught how to graph it. Now, so let's just quickly do this. Right. So you graphed, you had your axis, and then you said, okay, plot the 0, 1. And then you needed directions. So you said, okay, well, I have my directions. Up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. And so you graph it, you take your ruler, right? And you draw like that. But then you need to go the other way. Well, if you learn from, I think it's 5th or 6th or 7th grade math, that positive over positive is equal to negative over negative. So that's why this becomes down and to the left. What was this? 1? Oh, sorry. So this... Sorry, guys. Sorry. Yeah, so like this was down 2 to the left 1. Down 2 down 2 to the left 1, down 2 to the left 1, right? So that's where this came from. I shouldn't be making my own graph here, but that's not a good thing. Anyway, this should be reviewed. You've done this last year. So, but let's move on. So, so some examples you can do. So some examples you can do for y equals 2/3 x minus 5. So what's the first? So is this a line? Yes, it's in y equals mx plus b form. What are some information? Okay, well this is the y-intercept is -5, and the slope is 2/3. And so you plot 0, -5. I'm just going to do this really quickly. You plot like -5, and then you go like up 2 to the right 3, like up 2 to the right 3, and so on and so forth. And so you recall, clearly recall. You make the line perfect. Right now, I don't want to hand out graph paper. I don't want to use graphic stuff. I want to talk about how we can just look at the line and make a sketch. Because, once again, we're putting this into the computer. You have computers, you have Desmos everywhere, on your computer, on your cell phone. So let's just talk about the equation. So let's just make some observations about y equals mx plus b. So what I'd like you to do is I want you to go to Desmos, and I want you to put y equals mx plus b into your Desmos, and I want you to fool around with the sliders. Move the sliders for m and b, and I want you to come up with some observations about what the line looks like, or where it intercepts when m is positive, negative, when b is positive, what exactly b is. Okay, I'll give you pause the video and explore it. Okay, welcome back. So at this point, you should have discovered that first of all, y equals mx plus b is a line. The second you see something that kind of looks like that, you're like, it's a line. When x and y are alone, because you're going to see things like x squared, you're going to see things like 1 over x, radical x, you're going to see something in really advanced math class like xy equals 12. But if it looks like this, you have a line. Okay, first of all, if m is greater than 0, then the line's going up, it's increasing. Remember I told you to look at graphs moving from like left to right. So as you move from left to right, you go, oh, this is going up, like walking up a hill, it's increasing. If the slope, if m is less than 0, right, then the line is, then our line is decreasing. There's one more option. There's actually two more options. What's the first thing? Another thing. If m is equal to 0, then it's the slope. What do we notice? That it's kind of like walking, but no change. There's no change. What we're not going to be, what we could talk about, if you actually go to Desmos and type in the equation x equals 7, you'll actually see a line that looks like this. So let's say y equals 5, that's a horizontal line. When you have x equals 7, it's a vertical line. The slope is called, we're going to call it undefined. We're really not going to talk about this until we get to another subject, but we are going to focus on these three lines. The last thing is that the B is the y-intercept. Okay, and so now what I want you to do is I want you to say, you know what? If you give me the equation, Mr. Adler, I know I can put it in Desmos, but I can tell you some things about it. I can draw a sketch. So how about I give you the equation y equals 2x plus 3? So make sketching. I don't want a piece of graph. I don't have graph paper, but I can still make a sketch of these graphs. Y equals 2x plus 3. Well, you would say, you know what? It's a line. You would say, you know what, Mr. Adler? It's increasing because the slope is positive. You could also say the y-intercept is 3. And then you're ready to make a sketch. So you're like, okay, all I need is a ruler, because I'm neat and I always use a ruler in math. Right. Here's my y-axis. Here's my x-axis. I know this line passes through 3, and I know it's increasing, so I know it looks like this. Perfect. Is that what it's going to look like in the graph? Close enough. We know that on graph paper we have a little more work to do, but we're fine with that. This is just a sketch. Let's try another one. Y equals negative 3x minus 4. Right? Take a second. What are the characteristics? Pause. Okay, we're back. So, first of all, you know it's a line. Is that not clear? I'm sorry. It's a line. I know it's decreasing because that's a negative slope. Once again, I know what I have to do. You know, I know it's going to be down 3 to the right 1, down 3 to the right 1, but we're taking a step back from that. I know it's decreasing because the slope is less than 0. I also know that my y-intercept is negative 4. Okay, I'm ready to make a sketch. I'm going to draw my axis. Oh, I'm going to draw my axis. I can do it right on my notebook. I know that the y-intercept is at negative 4. Once again, maybe you say, well, it should be a little lower, Mr. Adler. You know what? It's a sketch. It's not a graph. And then I know it's decreasing. Nice. Should we try one more? Try this one on your own. Y equals 1/3 x plus 2. So try it on your own. Pause. Okay, great. Once again, we have a line. We know it's increasing. I don't care that it's a fraction. That number is positive. We know it's increasing. It's not increasing as much as 2x. It's not as steep as these two hills, but it's still increasing. Not that much. You know what I'm saying? We're only going up 1/3. Up 1/3. But it's still increasing. And that's good enough for my sketch. Once again, because the slope is positive, the y-intercept is positive 2, and so I'm ready to make my sketch. Make my sketch. Okay. Here's my sketch. We know that the y-intercept is at 2, and we know it's increasing. Last thing that wasn't in my notes from last year, but I realized I want to talk about is, you might say, hey, Mr. Adler, what's this intercept? What's that point? Am I still recording? There we go. Yeah, 20 minutes. Okay. So you might say, Mr. Adler, what are these points? Because they're known as the x-intercepts. These are the x-intercepts. How do we find these locations? Very easily, set the equation equal to 0. So you say 2x plus 3 equals 0, 2x equals negative 3, x equals negative 3/2. That makes sense. Let's try to find the y-intercept here. Set it equal to 0, negative 3x minus 4 equals 0, negative 3x equals 4, x equals negative 4 over 3. And the last one, I guess I coincidentally made all of these have negative x-intercepts. That's fine. 1/3 x plus 2 equals 0. 1/3 x equals negative 2. I hate denominators, so I'm going to multiply both sides by the denominator. 3 on the left, 3 on the right. X equals negative 6. Okay, I have another part, so I'll shut the cameras off.